This is Unit 8, Video 5, Sum and Difference Identities. Now, these are the identities that can be found on your formula sheet for the Regents exam. And I want to just first take a moment to explain to you why we would even bother to do this. If you look straight at exercise 2, it says find an expression for the exact value of sine of 75 degrees in simplest radical form. Well, I know how to do it for 30 degrees, 45 degrees, 60 degrees, 90 degrees, 0, 180, 270, 360. But I do not know how to find an exact value of the sine of 75. So what you need to think is, what two angles could I possibly put together to come up with 75 degrees? Well, if you think about that for a moment, and think about the angles I gave you as an example, perhaps you thought about the fact that the sine of 75 degrees is really the same as the sine of 30 plus 45. If you thought about that, you said, I can find the sine of 30 and I could find the sine of 45, but I don't know how to find the sine of 75, then you're already onto the right track. Since we looked at the sine of 75 and we said it's actually the addition of two angles, we can now go to our formula sheet, and it will be given on the Regents, like I said, and find a formula that has the sum of two angles and has the sine in it. And you can see it's the one I have selected. So as you think about this, the next thing you have to think about is that you can replace your original left side, the sine of 30 plus 45, with the right side. And what that would look like is the sine of 30 times the cosine of the second angle, which would be the cosine of 45, plus the sine of 45 times the cosine of 30. And that's just from plugging in A being the 30 and B being 45. So I plugged it into here. Now, remember those lovely triangles, or however else you choose to remember sine of 30 and 45 and so on? We're going to refer to them again. So maybe by now you've memorized this, and if not, you have your calculator and your triangles to help you. The sine of 30 is 1/2. The cosine of 45 is the square root of 2 divided by 2. Plus the sine of 45, so this is the square root of 2 divided by 2, times the cosine of 30, which is the square root of 3 divided by 2. And that should not be, I just had an extra parenthesis. Okay, so that means that now that we have that, we have to do a little bit of work. So I'm going to attempt to write this with the pen here in fraction form so you could see it better. 1/2 times square root of 2 over 2 plus square root of 2 over 2 plus the square root of 3 over 2, or times, sorry. And when you do this, in the first fraction, you do top by top, the first set over here. So I get the square root of 2 when I do 1 times the square root of 2. And on the bottom, I get 4. On the right set of fractions, I get square root of 6 over 4. The final step is to put them into one fraction. Now I can see that I'm adding fourths, so that means the bottom is going to be the same. But the square root of 2 and the square root of 6 are not like terms, so I cannot combine them. It's like adding an x and a y, so they're just going to stay in the top. So believe it or not, this is sine of 75 in simplest radical form. Square root of 2 plus the square root of 6 all over 4. Now if we look at exercise 3, they're referring us to the same idea, except they're saying the cosine of 15 degrees. So you may be thinking, okay, cosine. Well, she used 30 and 45 in the last one, so let me try subtracting 45 minus 30. Or you may be saying, no, I didn't think of that, Ms. Griffin. I thought of it as 60 minus 45. But in both cases, you should have been thinking of a subtraction problem. It doesn't matter which one of these we use, we're going to get the same answer regardless. So I'm going to work with the left one, and I'm going to leave you to verify the right one on your own. Hold on, made a mistake. So I'm going to leave you to do the right one all by yourself. So we're going to do this as the cosine of 15 is 45 minus 30. So that means I'm going to be looking for a problem that has a subtraction and has cosine in it. And I'm going to just change my highlighter. Here's subtraction, here's cosine, here's my formula. So when I'm doing this, I'm going to make sure that I'm careful. Nope, I'm not in the box. Sorry, guys. Cosine of the first angle, 45, times cosine of the second angle, 30, plus sine of the first angle, which is 45, times sine of the second angle, which is 30. So when you're doing this on the Regents exam, you know how I tell you to copy the formula every single time? Guess what? You still have to copy the formula. I just have not because of the amount of space that I have to complete this problem on this worksheet. But on your paper, make sure you're copying the formula that you are using. That way, if you mistakenly use a formula incorrectly, you can still get partial credit. I'm going to switch to the pen mode here so that we can see what I'm doing. Cosine of 45. Oh, I can all see you raising your hands right now. You get the square root of 2 over 2. Cosine of 30. Oh, once again, you're correct. Square root of 3 over 2. Sine of 45. Square root of 2 over 2. Right again. And sine of 30 is 1/2. So times 1/2. So now we're going to put this into place. And we get the square root of 6 over 4 plus the square root of 2 over 4. And when we're done, we add them together. We get the square root of 6 plus the square root of 2 all over 4. Wait a minute, Mrs. Griffin. I could see some of your brains clicking here. But are you telling me that the answer to both of these questions is the same answer? So I get this answer is the same as this answer. And that's true. It actually is another identity that's not written here, but we should be aware of the fact that if you have the cosine of an angle, it is the same thing in quadrant 1 as the sine of 90 minus that angle. And that is another Pythagorean identity idea here. So the cosine of an angle is equal to 90 minus the sine of the angle, and vice versa. Okay, so now on to the next page. Here they are written again so we can find them easily. And now they're going to give us a little bit more information. They tell us something that wasn't given on the page before. We know that this is in one and this is in the other. And now we have to find these values in simplest form, knowing less information than we knew before. So how on earth are we going to find these answers? Well, that's because we have our friendly triangles here. So we're going to make 2 triangles for each question. I'm going to walk you through A and see if we can get through that question quickly. So it says the sine of alpha. Sine of alpha here. Alpha is between 0 and 90 degrees, so that means, oops, wrong pen. We are in quadrant 1. Since the alpha is in quadrant 1, we know that both sine and cosine are going to be positive. Cosine of alpha is 3 over 5. That means that we're talking about the adjacent over the hypotenuse. So that means that 3 is adjacent, 5 is hypotenuse. Spend a moment. You can pause the video if you want. Use Pythagorean identity to get x. You should get 4. So sine of alpha is equal to the opposite over the hypotenuse. The opposite of alpha is 4. The hypotenuse is 5. And we're in quadrant 1, so this is going to be positive. Now we're talking about beta. Beta is between 90 and 180, so this is in quadrant 2. And while we're in quadrant 2, we know that cosine is going to be negative. So this is going to be a negative answer when we're done here. Okay? So we know that this is going to be opposite over hypotenuse. So this is going to be, if this is beta, opposite is 7, hypotenuse is 25. I'm going to call this y. Go ahead and use Pythagorean theorem to solve for this. I'm going to pause the video. Oops, didn't need to do that, so that I could get the answer. Hopefully you worked faster than me, and then you got that this was 24. So knowing that cosine is negative and it is really adjacent over hypotenuse, we can get that this is going to be a negative 24 over 25. So they aren't going to give you these mini steps on the Regents exam. They're going to tell you this and ask you to do one of the following. Find the sine of alpha minus beta or the cosine of alpha plus beta. It is up to you to know that you have to use the triangles to find the third side. Okay, I'm going to have you pause the video and I'm going to work through C and D and then I will talk through it. We're just running out of time. Okay, to run these through, sine of alpha minus beta uses the formula sine alpha times cosine beta minus sine beta cosine alpha. Oop, typo, that's okay. So sine of alpha is 4/5. Cosine of beta is negative 24/25. Sine of beta is 7/25. Cosine alpha is 3/5. You do the multiplication, then you subtract, you get negative 117 over 125. D uses cosine alpha, cosine beta, sine alpha minus sine alpha, sine beta. If you notice, this sign is always opposite in cosine, and it's the same sign in the middle in the sine formulas. You plug in your values, you do your multiplication, then you subtract, and you get negative 100 over 125, or negative 4/5. Now on to E and F. I went ahead and did those. These are double angle formulas. This is the sine of alpha plus alpha. This is 2 times an angle. You will see in tomorrow's videos that this is actually as a formula of all of its own. And if I plug in our value here, we get sine of alpha, cosine alpha, sine alpha, cosine alpha. And it's actually 4/5 times 3/5 plus 4/5 times 3/5 gives us 12/25 plus 12/25, or 24/25. If you look at this, this is cosine of 2 beta. You plug it into the formula cosine beta minus sine beta. Noticing that these are the same, so we just plug them into the formula that way. You plug in your values. When you multiply, you get 576 out of 625 minus 49 out of 625, which gives us 527 out of 625. Now quickly on to these multiple choice questions. So when you look at this, the first thing you have to do is say, hey, wait a minute. Cosine, cosine, sine, sine. That looks like a sum or difference formula. So now you go up and match. Cosine, cosine. What was that, plus or minus? Let's go back and check. Plus sine, sine. So we're going to use the cosine of alpha minus beta. So when you do this, it's going to be the cosine of 100 minus 20, or the cosine of 80 degrees. So which of the following is not the same as the cosine of 80? Well, the cosine of 80 degrees in quadrant 1 is not going to be the same as the sine of 80 degrees. So that is our answer. But you can verify this. This is the answer we got. This is the reference angle that we got. And if you tried to figure out any of the other ones, this is which one is equivalent, and we got this answer right here. This one's not the same because this is actually the cosine of 60 degrees in quadrant 2. So sorry I misled you. This is not the same. I read the question wrong, and this is not the same. Which is not equivalent to the sine of 70 degrees. Well, sine of 70, they're using 30 and 40 here. So we know that this is going to be 30 plus 40. And we're looking for not equivalent. So if you go to the formulas up here, 30 plus formula is sine 30 plus 40 is this formula. So it's sine cosine plus sine cosine. If we look at that, sine cosine plus sine cosine, that one works. This one would also work because 70 times cosine, or is it, this one would also work. So you have to think through it here. This is the subtraction formula. This one would be the one that works. This is the one that does not work. And this one does work because it's a Pythagorean identity. So the answer to this is 2. The answer to this is 4. And we are over time.